So we welcome our first speaker, Gabriel Puebla from the company QZabre, and he will talk about revealing magnetics at the nanoscale. So Gabriel, the floor is yours.
Thank you, Jack, for the really cool introduction, and once again, George, for organizing another incredible Quantum Industry Day. This is our third year that we've attended, and it just becomes a better and better event. Really, thank you so much for this. As mentioned, I'm CEO of QZabre. My name is Gabriel, and I'm with the startup company QZabre. And in the next 7.5 minutes, I'd like to talk about what we do with magnetic fields made visible at the nanometer scale. I'd like to start with going a little bit further back, and an open question that we actually came across a little while ago is, how does quantum sensing affect our everyday lives? And I've chosen a very specific example, but I think the overall principle will be the same. We all know that moment when our smartphone is getting low on power and we're looking for a power outlet. And we all know that battery technology is going ahead, but only very slowly. So there's a huge demand for energy efficient computing hardware. And several key technologies that are coming on the market right now are based on magnetic materials to really improve the energy efficiency. One is low power working memory. So magnetic MRAM, that's in production now, but it's still not a fully mature technology. But also on the CPU side, there's significant research on transistors based on multiferroics. It's actually already research done by semiconductor companies, and they offer really orders of magnitude improvement on the energy efficiency. The key issue is both of these use magnetic materials and both are nanoscale devices, but there are very, very few tools to actually characterize and do R&D on this. So really improving these devices needs the right tools, and this is where quantum sensing comes in. What we provide are the new and the very necessary tools to improve the devices that we have today. So we're really having an impact on the handheld devices that we use in our everyday lives in the future. However, we're always a little bit removed from the customer, so it's not as glorious as maybe quantum computing will make it look out to be, but it's really a crucial thing. So I believe quantum sensing is really something that will have an effect on our everyday lives. Now, you've already seen I've talked about magnetic materials. Obviously, what we do is related to magnetic materials. What we do is what we like to call nanoscale quantum microscopy. We work with nitrogen vacancy centers, which are defects in diamond. We use a single one as an atomic scale magnetic sensor that we scan over a surface. It's a very powerful method. We get very high resolution, in theory 10 nanometers, in practice 30 to 50 nanometers, and very, very high sensitivity. So if you, in the number game, it's microtesla and nanotesla per square root hertz. The really neat thing about this is it works in a desktop size system with ambient conditions. And if you want similar data right now, you actually have to go to a synchrotron facility, which is this government operated building size structure. And our system with nanoscale quantum microscopy, you can actually own your own system. This makes it much faster. You don't have to apply for waiting times, and it's a lot less expensive. So these are really the key issues to go here. The NV itself is an incredible versatile sensor. So I'll be focusing on magnetic fields mainly, but it can do a lot more, and it can do a lot more with the same setup. So you can actually choose in the software what kind of measurements you want to do, and you get more like a Swiss Army knife type of instrument. So we can also do electric fields, you can do temperature, you can do near field imaging. In principle, you can also do first resonant energy transfer. So there's this wide range of applications. But in the beginning, we really focus more on the magnetic side. So some example measurement modes. I talked about multiferroic structures at the nanometer scale. So in the top left-hand side, you can really see images. So there are bright spots, which are very, very tiny. They're actually only 30 nanometers. These are areas of interest that we can actually image. Currents also create magnetic fields. So current distributions is something really nice. In this case, it's graphene. You can really say current crowding around defects. We can also do imaging of metals much below the normal optical diffraction limit, and actually also below capping layers. So this is another nice tool for the semiconductor industry. And last, we can do waveform reconstruction. So instead of moving in space, we can look in time, and you see very tiny, the dashed line, a very arbitrary waveform, and in blue, the reconstructed waveform. So we actually have an atomic size oscilloscope that does not interfere at the nanometer scale with your devices. This brings me a little bit more towards QZabre itself. So we believe in creating a system with the maximum performance, and to do that, we really need to engineer all the different aspects of a system. So we started as a diamond tip company, but we also believe in working very hard on the hardware end, doing our own optics, also on the algorithm end. And only by engineering all these three aspects and their interaction together can we really deliver that peak performance that we want the customer to have. And this ends up in our product. This is the quantum scanning microscope. Of course, we also offer tips. So we optimize the tip shapes for maximum collection efficiency and performance. On the other hand, we also work on our system to have enhanced optics to really improve as much as we can signal to noise. We want this turnkey system to be user friendly. So we do a lot on the software side, but also on the hardware side. For example, you need a microwave line. Usually you have a stage that you need to align. In our case, we actually have the microwave antenna integrated. So you just change the tip and that's it. No more fiddling around with antennas. We also believe in bringing new technology to the market. So a few weeks ago, we were able for the first time to offer in-plane NV scanning tips. So this is something that's not even been demonstrated in papers before and that you can now buy in our store, with the NV axis not being 45 degrees, but in plane. On the instrument side, we'll offer vector magnets so that you can sweep magnetic fields. This is a nice extension to have, and overall our system is made to deliver sub-microtesla per square root hertz DC sensitivity. And with that, we're pretty much already done. So quantum sensing is something that's really going to have an impact on our lives, and NV is really part of that. It offers a wide variety of tools for R&D, and this is all in the same system. QZabre itself is an ETH spin-off from the Ding Group, founded 2018. We're financed by revenue and government grants, and we're really experts both in tip fabrication and instrument design. And with that, I'd like to thank your attention. Just get in touch with us. We also offer service measurements as an easy entry into the quantum scanning world. If you're a master's student or interested in internships, get in touch with us. Thank you for your attention.
Thank you so much, Gabriel, for this pitch. It's always very nice to see that starting are working, are happening, and we are looking forward to have more and more of these startups coming out of the quantum research field. I hope there are some questions. George, could you get some questions from the chat?
Well, the chat can be a little bit more active. I'm taking here the lead because I would first like to thank you, and also I'm a little bit proud of seeing 3 startups now in this session, and I feel like quantum sensing is one of the most one of the sessions where you can see that this technology is very close to reality or to our own daily life. My question would be, can I just buy, as a research group, can I just buy such a scanning microscope from you now?
Yes, it's available now. It will have a little bit of lead time, but you can buy this, and once you get it delivered, it will run from day one.
Great, thanks. I move back to Jack.
Yeah, in the same kind of question. So you have this is your first product. What do you see at the future? Having more flexibility on the samples or on the tips, or how do you see the future of your products?
I think there's really demand on the industrial side. Right now we're making systems that in terms of range and speed are more on the academic side. So there is a lot of research needed to improve sensitivity so that we can actually speed up, and not at the expense of sensitivity, but really increasing that so everything goes faster and we have a bigger range. Right now, we do small samples. The industry likes to do 8 and 12-inch wafers. We have to kind of converge towards their needs on that end.
Okay, so I hope you are going to be able to meet these new specifications.